Hey guys, I wanted to make another video, and this time I want to talk about autism and how it shows up actually in the brain. So there's this university called the Medical University of Lublin. It's in Poland, and they ran 3 different studies on children with autism, and they were trying to understand, is it like a brain structural level? Is there something different? Can it be seen in MRIs? And I'm going to tell you a little bit about what the results were. Now, these 3 posters were posted at the 23rd Annual Neurotech Conference here in Los Angeles. I'm going to post pictures of that as well. And all the credit goes to the Medical University of Lublin in Poland. But very, very interesting studies. Now, the first study is, I have my notes over here, but the first study was in seeing MRIs, are they able to see any particular differences versus the brain structure in a child without autism, or shall we say a neurotypical child? Now, what they saw is when they analyzed all of these MRIs from the children with the autism, they found that actually 56% had very subtle abnormalities, very, very hard to identify abnormalities. And these abnormalities were being shown more in the white matter. Now, guys, white matter in the brain is what carries all the communicating nerves, if that makes sense. Gray matter is more like the nucleus, and the white matter is basically, imagine like highways. That's how they talk to each other. The neurons talk to each other. So there was changes in white matter. There was delayed myelination. Oh, my pronunciation sucks. And there were also slight asymmetries in brain structures. And the key insight from the first poster was that although the brain may look normal just at first glance, when you really look deeper, there are subtle differences that was being shown in 56% of the children. Now, another thing that they did was they had these children with autism, and they tried to measure the brain volume and trying to see if we can use that as a biomarker, maybe with a particular brain volume, does that show differently in autism? And they used an automated MRI analysis to compare the gray matter, white matter, and then overall the total brain volume. And this was done between children with autism and without autism, or the neurotypical children. And an interesting insight was that there was actually no difference. So what does this show so far? So far, we see that there is very subtle structural difference, but not as much volume difference, if that makes sense. Now, the third study that was done was on the brain development timing. And this is basically where they're taking it even deeper now, the study even deeper. And they're trying to look at how the child's brain with autism is developing over time. And in about 56% of the children showed differences. But this time, they showed differences in how fast certain brain regions were maturing, patterns of the white matter development. Remember, white matter is the communication gateway between the different parts of the brain, between the different neurons, and then overall developmental trajectories. And so in the third study, they saw that instead of just structural abnormalities, they were also seeing differences in timing and the patterns of maturation. So this suggests that in autism, the brain is definitely developing differently. Okay, so we see that, there are structural very subtle structural differences that's hard to see from the eye, just like that in MRIs. But when you really start to look closely into it, you can start to see those. You can really identify those differences. Now, during my studies, one thing that I've been studying in my biomedical neuroscience is, if you know me, you know I have autism myself. I am on the spectrum as well, along with ADHD. Now, this manifests itself in so many different ways, but it allows me to think from inside out, if that makes sense, because I experience it. And since I experience it, when I learn about all of these different structures in the brain and how they are supposed to be working, and how in my brain it is a tad bit different, that's when my brain starts like, okay, so there is definitely a difference there. Now, from my experience, what I've studied is that, or I've observed, is that the synaptic circuits are very different. Now, you remember yesterday I was talking to you guys about the excitatory or the inhibitory signals that neurotransmitters release. And the presynaptic terminal, this is what Dr. Thomas Sudoff got his Nobel Prize for. Figuring out how the neurons speak to each other via synaptic transmission of these neurotransmitter fluids, or these neurotransmitter chemicals, not fluids, chemicals. So what happens is in autism, I feel those neurotransmitters are the ones that are creating that major difference in the way we think. Now, some of the key brain regions that I have definitely identified as the ones that cause or that contribute to this huge difference in the way our brain works is, number one, the limbic system. Limbic system controls the emotions, the threat, and social meaning. For those on the spectrum and those people who have autism, they have basically an overreactive amygdala, which which leads to heightened emotional responses, stronger reactions, and it's like it's overactive in that way, which means high level of excitatory. It's also one of the reasons that a lot of people who have autism do also have a high level of anxiety, and then they need to also take anxiety meds, which has GABA neurotransmitter, which actually works as an inhibitor. An inhibitor basically calms down the synaptic transmission and basically makes them less like excited. Imagine the neurons are like, like talking and they're like screaming at each other. So it's like, guys, settle down, and it calms those neurons down. Another one, very, very important, and I think I've spoken about this multiple times, is the prefrontal cortex. When someone on the autism spectrum has a meltdown, their meltdown is not just the limbic system going in overdrive. Rather, it's also the prefrontal cortex going offline. It goes on vacation. But what does that mean? That means the logical thought process goes away, and there's something called executive dysfunctioning or executive dysfunction that happens, which means in that moment, we're not able to produce that proper thought process. And if anything, there's only an emotional thought process. So oftentimes you'll see someone who's on the spectrum that's having a meltdown. They'll just be like saying random words and crying because they themselves don't have the power to really logically understand what's going on. And guys, if someone's having a meltdown, don't ask them what happened, what triggered it, because for sure they probably don't know. It's so that's why I'm making everyone aware. So most probably they will not have an idea. And another area of the brain is the temporal lobe, and this takes care of the social processing. And on the spectrum, this area is under or lower responsive, which leads to the difficulties in social interaction and social communication. So I think we're definitely on the right track to really understanding how autism is, but I think we're still trying to make a clear picture of the biomarkers of autism and how to basically see it at a neuroanatomical level, if that makes sense. I think that would be really helpful in early detection of autism, especially in children, so they can get earlier treatments to help them develop and get, the types of therapies to help them develop from a social perspective. And at the end of the day, guys, autism is not a disease. It is a difference in the way the brain works. But at the, I feel like as we're moving forward and we are evolving as a civilization, I think AI is going to play a huge role in actually being able to detect autism from a much deeper level and maybe even be able to be integrated into therapies to help support it. But that's it for today, guys. Bye.